Today in our class we are going to learn about how to deal with numbers with powers. So here when I say 6 is raised to power 3, then I write this as 6 raised to 3. So 3 is called the index. Or you call it power, or you call it exponent. So generally we call it as index or an exponent. The plural for index is indices. So this chapter what we are dealing now is called indices or exponents. Okay, plural for it. Now what does this mean? When 6 is raised to 3, 6 is multiplied by itself 3 times. 6 times 6 times 6, and the answer is 216. So when I write 5 squared, it is 25. What about negative 3 raised to 4? It is negative 3 multiplied 4 times, and the answer is positive 81. So when you will notice that when there are even, when the power is even and the base number is negative, the result will be a positive quantity. So here the base number is negative 3, whereas the power is 4, an even number. So you get the result as positive 81. Now there are laws which you have to follow. They are called the laws of indices, which you have to strictly follow when you work with exponential numbers, exponents or indices. So we call them laws of exponents or laws of indices. The first one is a raised to m into a raised to n is a raised to m plus n. This I call this as a product rule because we are multiplying two exponents with the same base. So this is called the product rule. Now how does this work? Consider this 2 raised to 2 and 2 raised to say 3. We take small power so that it's easy for us to learn it. So this 2 is multiplied 2 times. Here this 2 we are multiplying 3 times. This 2 is repeated 3 times. So on the whole it is repeated 5 times. 2 raised to 5. That's how we get this product rule, where the base numbers being the same, the powers are added. Now the opposite here when it is division. A raised to m divided by a raised to n is a raised to m minus n. Now this also we can take a small example. 5 raised to 3 divided by 5 raised to 2. So here 5 is multiplied 3 times and it is divided by 5 multiplied 2 times. So you cancel 2 5s and you are just left with 5 raised to 1, which is 5 raised to 3 minus 2. So when you divide two exponents with the same base, you subtract the powers. Now we are only discussing positive indices now, as of now. Now this rule is called the quotient rule. I call it the quotient rule. In some books they do mention, but mostly it's better for you to remember as product rule or quotient rule. Now third one, if I have a power, an exponent a raised to n, and that itself is raised to another power n. So this is a raised to m times n, mn. Now it's also possible to interchange the n and m. So it can also be considered as a raised to n and all of it is raised to m. Now let us take another small example for this also. 2 raised to 2 raised to 3. Now 2 raised to 2 is 4. I do what is inside the brackets first, and which is raised to 3. So 4 times 4 times 4, which is 64. Now I'm going to do m into n. 2 times 3, 6. So what is 2 raised to 6? 2 multiplied by 2 multiplied by 2, 6 times, and that also gives me 64. Now what about 2 raised to 3 raised to 2? Now this is 8 raised to 2, which is 8 times 8, that's also 64. So you can understand that 2 raised to 2 raised to 3 is the same as 2 raised to 6. It's also the same as 2 raised to 3 raised to 2. And this I call it as the power rule. Very useful, and you have to follow these when you work with exponents. Now let us use these rules and we'll do some simplifications, 1 or 2. Simplify and leave your answer as exponents. Simplify, leave your answers in the exponent form. So consider this 4 raised to 3 into 5 into 4 raised to 2 into 5 squared. Now you have to select those exponents with the same base. So here these two have the base 4 and these two factors have the base as 5. So we'll combine those. Now 4 raised to 3 and 4 raised to 2, when you multiply, you know that multiplication is commutative and it's associative as well. So you can associate the two numbers with the same base. 4 raised to 3 into 4 raised to 2 we do first, and then 5 times 5 squared. Now all this rearrangement you have to do it in your mind. Don't be wasting your time writing it out like this. This has to be done in your mind. So this is 4 raised to 3 plus 2 times 5 raised to 1 plus 2. When the exponent is not written, it is just 5 raised to 1. So your answer is 4 raised to 5 times 5 raised to 3. You can just keep a dot to show that these are multiplication. It's multiplication. 4 raised to 5 times 5 raised to 3. Now we'll do one with 5 raised to 7 divided by 5 raised to 3. It is just 5 raised to 4. Now the third one, 9 raised to 2 raised to 3. Multiply the powers in and out, 9 raised to 6, power rule. Then the last one, 5 raised to 3 raised to 4 multiplied by 5 raised to 3 multiplied by 4 raised to 11 divided by 5 raised to 8 times 4 raised to 8. So select the numbers with the same base and then combine them. That's the whole idea here. So using the power rule, it is 5 raised to 12 times 5 raised to 3. And then these two, 4 raised to 11 divided by 4 raised to 8 can be combined because these are the only two numbers with base 4. 11 minus 8. Here I have 5 raised to 8. Now, combining these two on the numerator, 5 raised to 15 divided by 5 raised to 8. 4 raised to 11 minus 8 is 3. And here 15 minus 8, 7. So my final answer is 5 raised to 7 times 4 raised to 3. So these three rules, they are product rule, quotient rule and power rule. You have to remember and use it just as how we did in these examples. Now what about zero index? What do you mean when the power is 0? Now for this, let us try to find out what is 3 raised to 4 divided by 3 raised to 4. Writing this 3 raised to 4 divided by 3 raised to 4, writing these as a rational number, 3 raised to 4 is 81, divided by 81 is 1, isn't it? Any number divided by itself gives you 1. Now what if I use the quotient rule here? 3 raised to 4 divided by 3 raised to 4 is 3 raised to 0. So 3 raised to 0 is 1. Now let us consider negative 5 raised to say 2 divided by negative 5 raised to 2. Now negative 5 raised to 2 as a rational number is 25, positive 25, divided by 25, that also gives me 1, isn't it? So this is another example I am giving you with a negative base. Now this also, when I use the quotient rule, it is negative 2 raised to 2 minus 2, which is negative 5 raised to 0. That's also 1. So even a negative number, when it's raised to 0, gives you the answer 1. But remember, the negative number has to be enclosed in parentheses. When I write negative 5 raised to 0, then it is just negative 1. Why? Because the parenthesis is not there. It's only the 0. The power 0 is only for the 5. Okay, you have to be careful about when a negative number is raised to 0. Just check if the negative number is placed in parentheses, or whether the minus sign is not for the power is not, the negative sign is not for that power 0. It's only 5 power 0 with a minus sign. So 5 power 0 is 1. So it is minus 1. So you have to see that difference. So if when I say minus 6 raised to 0, it is 1. But at the same time, when I say minus of 6 raised to 0, it's minus 1. How the parentheses are placed, that makes a difference. Now we'll move on from 0 index, we'll move on to negative index. Now when I say 3 raised to 2, it makes sense. 3 times 3, 9. But when I say 3 raised to negative 2, how can I multiply 3 negative 2 times? What is the meaning of multiplying negative 2 times? So what is it? Now again we'll make use of the quotient rule. It helps us to understand what this negative index means actually. So when I write negative, how to get negative 2? So if I want to write 3 raised to negative 2, I can write it as 3 raised to 1 divided by 3 raised to 3. Isn't it? So this will give me 3 raised to 1 minus 3, which is 3 raised to minus 2. Isn't it? So when I use the quotient rule, I am getting 3 raised to negative 2 as 3 divided by 3 raised to 3, which is 3 by 27, which is 1 by 9. Now you compare this 1 by 9 to 3 raised to negative 2. So 3 raised to negative 2 is equal to 1 by 3 squared. So what do you notice here? When I write 4 raised to minus 3, it will be 1 by 4 cubed. So the rule now for negative index is a raised to negative m is equal to 1 by a raised to m. So once I convert the negative index to a positive index like this, then I know what to do. Here I will just do 4 times 4 times 4 in the denominator, which is 1 by 64. So one more example, when I write 2 raised to negative 5, that means it is the same as 1 by 2 raised to 5, which will be 1 by 2 power 5, which is 32. And here I would give a small tip here for you to do the calculations faster. You should memorize certain powers of 2 and powers of 3. So 2 power 1 is 2, 2 squared 4, 2 cubed 8. It should come to you automatically. You should be familiar with all these answers. 2 power 4, 16. 2 power 5, 32. 2 power 6, 64. Up to 2 power 10, 128. 2 power 8, 256. 2 power 9, 512. And 2 power 10, 1024. I'm sure some of you would have played the game 4026. 4028, sorry, yeah, twice. 4026. 4096. Yeah, 4096. That will be 2 power 12. Yeah. Now, having learned the negative powers also, let us do some calculations. What is 9 power minus 3 divided by 9 raised to negative 4? So use the quotient rule. Just use the quotient rule. Negative 3 minus minus 4. So that becomes 9 raised to negative 3 plus 4. That will be 9 raised to 1, which is 9. Now solving exponential equations. Next is solving exponential equations. Solve 2 raised to x plus 2 is equal to 512. Now just now we saw the powers of 12. So 512 is 2 power 9. And therefore if you match the powers, x plus 2 should be 9 and x has to be 7. And some powers of 3 also you should be familiar, up to 3 power 5. 3 squared is 9, 3 power 3 is 27, 3 raised to 4 is 81, and 3 raised to 5 is 243. Now let us solve this one more equation. 3 raised to negative x plus 1 is equal to 1 by 243. So I just said 243 is 3 raised to 5. So 3 raised to minus x plus 1 is equal to 1 by 3 power 5, which can be written with a negative exponent as 3 raised to minus 5. You are shifting the 3 power 5 from the denominator to the numerator. You change the sign of the power. So match the powers now. So here the power of 3 is the power of 3 is negative x plus 1, and here the power of 3 is minus 5. So you match them and solve. You get a linear equation. Minus x plus 1 is equal to minus 5, negative x is equal to negative 6, and x is equal to 6. So since we are now familiar with the quotient rule, product rule, power rule, and the negative index, zero index, we are now moving on to the standard form of a number. It is also called scientific notation. Why scientific notation? Because it's very often used in science like physics, chemistry, where you have to measure the size of the diameter of an atom maybe, or a molecule, or in physics, in astronomy, you will have to measure the distance between planets, the speed of light, the speed of sound, which will involve very large quantities or sometimes very, very small quantities. And to write them in the standard form makes it easier to recognize, and they also to carry on with calculations with those numbers. Now, what is the scientific notation or the standard form? So, when you have a number, you are going to write it using a power of 10. See, and there is a format for that. So, when I have 721 million, this is a huge number, and I have to carry out calculations with this number. Imagine writing these 6 zeros again and again. It's going to be difficult, and sometimes we may miss out 1 or 2 zeros also. So to put them in the scientific notation, you write this in the form a times 10 raised to n. Now this a has to lie between 1 and 10. It has to lie between 1 and 10. And n should be, and n is an integer. So keeping this in mind, let us see how to write this 721 million in the standard form. So I write it as 7.21 into, now if I place the dot here, how to account for the rest of the digits? I have to write it as 10 to the power of 1, 2, 3, 4, 5, 6, 7, 8. So when I multiply by say 100 million, then that point moves and you get this number 721 million. So 7.21 into 10 to the power of 8. Now you will notice that the 7.21 lies between 1 and 10. It's greater than 1 and less than 10. And here you have a power of 10. So the scientific notation or the standard form of 721 million is 7.21 into 10 to the power of 8. Now we'll do one more example. I'll take a smaller number, 54,000. I can write this in the scientific form, the standard notation as 5.4 into 10 to the power of 4. Now how do I do it? You can just keep one. You can draw an imaginary line here and see how many digits. 5.4. So this is 5.4. How many digits are there after this imaginary line? 1, 2, 3, 4. So 10 to the power of 4. So you can do that quickly. So now let me do 128, 1280. Maybe I can add any number of zeros. I'll stop here. So if I want to write this in the scientific notation standard form, it is 1.28. Now count the number of digits after this line. 1, 2, 3, 4, 5, 6, 7 into 10 to the power of 7. As easy as that. Now let us consider small numbers, very, very small quantities, 0.00016. Now remember, even this has to have the same format, a into 10 to the power of n, where a lies between 1 and 10. So in order to write that format, now the imaginary lines is over here. You are moving it forward. So it is 1.6 into, since you are moving it forward, that means you are multiplying it by 1, 2, 3, 4, 5, 10 to the power of 5. Only when you multiply this decimal by 10 to the power of 5, the point is going to be placed between 1 and 6, 1.6. You get 1.6. Now how to compensate that? Now you will have a negative power, 10 raised to minus 5. Here also you count how many places this decimal has moved. 1, 2, 3, 4, 5. So it's 1.6 into 10 to the power of negative 5. One more example. Now here the point has to move 4 places forward. So 5.44 times, compensate that moving forward, 10 to the power of minus 4 with the negative sign. So when you move the point forward, compensate with the negative sign, negative 4. So this is how you write numbers in the standard form. Now let us see some practical applications of this. Say the mass of hydrogen is given as 0. It's a very small, very small quantity. 1, 2, 3, 4, 5, 6, 7, 8. So here you have, I'm going to see, so that I don't miss out any zeros, I'm going to divide them in groups of 3. So 4, 5, it continues, 6, 7, 8. Here you have a 1. The first significant digit after the decimal point appears here, and after that you have a 67 grams. So that's so much less. The quantity is so small. So how to put this? Now definitely we cannot be writing this every time. We have to put it in the standard form. So I'm going to write this. The point has to move over here. So 1.67 into 10 to the power of negative 24. 1, 2, 3, 4, 5, 6, 7. 7 threes are 21, 23, 24, 25 is it? 1, 2, 3, 4, 5, 6, 7. 21, 23, 21, 22, 23, 24. 22, 23, 24. So it is 1.67 into 10 to the power of minus 24 grams. Now this is also used in population. Now population of China at a certain period was estimated as 1. How do you read this number? 1,100,000,000. So how do I write it in the standard form? 1.1 and see how many digits after that. 1, 2, 3, 4, 5, 6, 7, 8, 9. So into 10 to the power of 9. That is the population in standard form. Okay, so these are, so you will see that they are used in when you are dealing with very large quantities or with very small quantities. So we'll do some calculations with this. That is, calculate and leave your answer in the standard form. (150 times 0.0006). Now how do you multiply a decimal with a number? Just multiply 150 and 6. And that gives you 900. But now you take care of the decimal. How many? 4 decimals you should have. See, you have 4 in the 2 factors that you have totally 4 decimal places, but I have 3 here. 1, 2, 3, I add a 0 and keep the point over here. So this is the product, 0.09. Now how to put it in the standard form? It is 9.0 moves forward into 10 to the power of minus 2. So this is the answer in the standard form. Next, 0.002 raised to 4. Now what is 2 raised to 4? 16. And here there are 3 decimal places. And the 3 decimal places, when you are going to multiply the decimal with 3 decimal places 4 times, there must be 12 zeros, 12 decimal places. We already have 2, then you will have 10 zeros over here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now putting it in the standard form, it will be 1.6 into 10 to the power of 11, minus 11. What is the other way of doing it? Let me try to put that 0.002 in standard form. That will be 2.0 into 10 to the power of minus 3. That you raise to 4. Okay, so now this 4 is common to 2. It belongs to 2 as well as 10 to the power of minus 3. So this is 2 raised to 4. I can shift the 4 to 2 and also to assign it to 2 as well as to 10 to the power of minus 3. So 10 to the power of minus 3 raised to 4. So this is 16 times 10 to the power of minus 12, which once again 1.6 into 10 into 10 to the power of minus 12. Combine these two tens, 1.6 into 10 to the power of minus 11. So if you find this method easier, you can do it by this method, converting the number in the beginning itself to standard form and raising it to 4. Now 400, now this is easy, 400 raised to 3. Now 4 raised to 3 is 64 and the zeros, they tripled. So that will be 6.4 into 10 to the power of 7. Or as I said, you can convert 400 to standard form and then raise it to 3. Now what about addition? So let's see, 3.1 into 10 to the power of 6 plus 8.5 into 10 to the power of 6. Now here this 10 to the power of 6 is common, so by distributive property you can factor it out, and then you are left with 3.1 plus 8.5. So that will be 10 power 6 times 11.6. But this is not in the standard form. Why? Why not? 11.6 is greater than 10. That number, that A has to be between 1 and 10, remember. So I write this as 10 power 6 into 1.16, so that it lies between 1 and 10 into 10. Now combine these two tens. Combine the powers of 10. Then you get the standard form of the answer. So 1.16 into 10 to the power of 7. Now last example. Now I am giving x as, here I am giving x as 2 into 10 to the power of 5 and y as 3 into 10 to the power of minus 3. Okay, so they are already in the standard form. I want you to calculate x by y and x times y. Now for x by y, it is 2 into 10 to the power of 5 divided by 3 into 10 to the power of minus 3. So that will be 2 by 3 times 10 to the power of 5 minus 3, quotient rule. So 2 by 3 is 0.667. I'm just writing 3 decimal places because it's a recurring decimal. Remember, into 10 to the power of 8. It is not in the standard form. This number has to be greater than 1. Or maybe equal to 1 is fine, but not less than 1, and it has to be less than 10. So this I write as 6.67 into 10 to the power of minus 1 into 10 to the power of 8. So I get the answer as 6.67 into 10 to the power of 7. Now what is x into y? I think that won't be a problem. X into y will be 2 into 10 to the power of 5 times 3 into 10 to the power of minus 3. Multiply the two numbers. 2 times 3 is 6 into 10 to the power of 2. It's already in the standard form. So this is about standard form and scientific notation. When you do calculations, be careful. And if they expect you to give the answers in the scientific notation or the standard form, make sure that the number other than the one that you are giving, other than the power of 10, lies between 1 and 10. Now we will move on to the final step, the concept in this lesson, which is fractional indices or the rational indices or the rational index. You call it rational index or the fractional index. Now, what is the meaning of 8 raised to 2 by 3? Now here the power is 2/3. See, when it is a whole number, I know how many times I should multiply. If it is a negative integer, I know I bring it to the denominator, and in the denominator I can expand. But what is this 8 raised to 2 by 3? Here this has, we have already learnt about cube roots, square roots. So we bring in that knowledge here. It is cube root of 8 squared. The denominator tells you what is the order of the root, order of the radical. So here it is cube root of 8. Now, so this cube root of 8 will be cube root of 64. And cube root of 64 is 4. So it makes sense to write like this. Or the other method would be 8 raised to 2 times 1 by 3. You split it. 2/3 is 2 times 1 by 3. So now you can write 8 raised to 1/3, that is raised to 2. Now this can be written as a radical as cube root of 8 raised to 2. And cube root of 8 is 2 and 2 raised to 2 is 4. You get the same answer. So whichever method is easier for you, you can adopt that method. The best would be this 8 raised to 2 by 3. Instead of converting it into radical, try if you can use exponents itself, keeping it in the index notation itself. So here 8 can be written as 2 cubed, isn't it? 8 is 2 cubed. This 8 I can write as 2 cubed. And that is raised to 2 by 3. So what I have here is 2 cubed raised to 2 by 3. Now using the power rule, it is 2 raised to 3 times 2 by 3. That 3 cancels out. You get 2 raised to 2, which is 4. This I feel is the easiest method of all the 3 methods which I have listed. First one taking the cube root of 8 squared, or taking cube root of 8 and then squaring it, or writing 8 as a power and then raising it to the power 2 by 3. So, in general, when I write a raised to m by n, it means that it is the nth root of a power m. Or you can write this as a raised to 1 by n whole raised to m, or you can also write it as a raised to m whole raised to 1 by n. These are all equivalent statements. Now we will do some evaluation so that you are familiar with rational exponents. Now let us write what is 125 raised to 1/3. Now 125 is 5 power 3, raised to 1 by 3 is 5. What is 16 raised to 3 by 4? 16, see I prefer the writing it as exponent rather than using the radical wherever possible. So 16 I know is a power of 4, is a 2 raised to 4, and that is raised to 3 by 4. Now that 4 cancels out, you are left with 2 cube, and the answer for 2 cube is 8. So 16 raised to 3/4 is 8. Now what is 0.001 raised to 4 by 3? Now 0.001 is 0.1 raised to 3. And that whole thing is raised to 4 by 3. Cancel it out. It is 0.1 raised to 4. Which means I should have 4 decimal places. So you can also use it in certain decimals like this. And then what about if the numbers are not perfect cubes or perfect squares or anything which I cannot write and then cancel out the powers like this? Use your calculator. So for example, if I want to do 17 raised to 2 by 3, you write cube root of 17 raised to 2, which is the same as this, but in your calculator you can type in 17 and then you can type that power, that raised to power, then again open parentheses 2 divided by 3. 2 by 3, the fraction is the same as 2 by 3, but please remember to insert parentheses.